I welcome you all to this mathematics class. I'm Miss Vandana Gupta, Assistant Professor of Mathematics. We are in section 1 mathematics. In that, unit 2 permutation, combination and linear programming problems. This unit has got two subunits. First one is permutation and combination and second one is linear programming problems. In my last lecture, we started with permutation and combination. Today we are going to continue with this. In the last lecture, I introduced you with the fundamental principle of counting and also the factorial notation. Today I'm going to begin with permutation. Now what is permutation? Permutation means arrangement. Okay, so before I actually begin with the formal definition of permutation, let me explain you with the help of one example. Suppose there are three people, A, B and C. These are three people and I have to arrange these people in a row for a photograph. Okay, listen to my what I'm saying. Listen very carefully. There are three people, A, B and C. I want to arrange them in a row for a photograph. So what I'm doing an arrangement. There are three chairs here, or three places, you can say three chairs. I have to make them sit on these chairs for a photograph. My question is, how many arrangements are possible? In how many different ways I can make them sit on these chairs? These are the chairs, these are the people. Okay, these are three people or three persons and these are the chairs. I want to make them sit on these chairs for a photograph. I want to find out in how many different ways I can arrange these people to sit on these chairs. So let us see. Suppose I make this person A sit on this chair. Okay, B here and C here. This is one arrangement. Okay, next time what I can do, I will make person A to sit on the chair number 1. On chair number B, I make the third person C. And on chair number 3, suppose these are the chairs 1, 2, 3, B. Okay, so these are two different arrangements, right? In the first arrangement, B is occupying the second chair and C is occupying the third chair. In this arrangement, C is occupying the second chair and B is occupying the third chair. So these are two different arrangements. In this way, I have to count how many such arrangements are possible. Next, what I can do, I'll make on the first chair, I'll make B to sit. And on second chair, A, and on the third chair, C. Then B on the first chair, on the second chair, C, and on the third chair, A. Okay. Then I can make C sit on the first chair, A sit on the second chair, and B sit on the third chair. Or C on the first chair, B on the second chair, and A on the third chair. So in this way, I see that I have how many such arrangements possible. This arrangement 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So in 6 different ways, I can make them sit on the chairs for the photograph. Okay. Similarly, if there are 4 people, see, there will not be any more, 60 honge ye. How will you count that? See, first of all, how I have done this, let me tell you. First, I have fixed on the chair 1. Suppose on chair 1, person A sits. Then what are the possibilities on these two chairs, B and C? Okay, A I keep fixed, B and C. So second second chair, I make B sit, and on the third chair, C. Next time what I do, I'll exchange. C will sit here and B will sit here. These are the only two options with me when A sits on the first chair. When I make B sit on the first chair, for second and third chair, I have two options, A and C. So in first option, I make A sit on the second chair and C on the third chair. And in the next one, again B on the first chair and AC, I will make it CA. So with B on the first chair, I have two arrangements, BAC and BCA. I hope you are understanding. Then what I do, I make C sit on the first chair. So C is here. Now how many are remaining, A and B? So I will make A sit on second chair, B sit on third chair. And in the next arrangement, B sitting on the second chair and A sitting on the third chair. And I think these are the only 6 possible arrangements of these 3 people on these chairs. Okay. So how many I'm getting? I'm getting 6 such arrangements. 6 arrangements are possible. Okay. Are possible. In similar way, if there are 4 people, A, B, C, D, and there are 4 chairs, suppose there are 4 people, A, B, C, D, and there are 4 chairs. And if I ask you, I want to make them sit on these chairs for a photograph, how many different arrangements you can make? You can work on it. Okay, जैसे मैंने ये किया वैसे आप ये भी कर सकते हैं. And you will notice that there will be 24 such arrangements. You can do this at home. Okay, first you can fix the first place as A, fix the second place as B, and then first will be CD and then DC. Okay, so with first two AB, ABCD, ABDC, then you do A here, and at the place of B take C. So ACBD or ACDB. Like this you can count, and you will notice that you will have 24 such arrangements. Okay. Similarly, if you have 5 people, then also you can do it. 6 people, you can do it. Okay. Now, see, in the example which I just gave you, there were 4 people and 4 chairs. What if number of chairs are less? Suppose, I'm sorry, three people. There are 3 people and there are 3 chairs. Suppose there are only 2 chairs. Chair number 1 and chair number 2. Okay. And I want to, out of these 3 people, I want to take 2 people out of these 3 and make them sit on these chairs for a photograph. How many such arrangements are possible? See, I have only 2 chairs, so I can only select out of these 3 only 2 people. Okay, but I have to see all possible. Okay, all possible arrangements. So suppose I select A and B. So first chair will be occupied by A and second chair will be occupied by B. In the same selection of A and B, I can have BA. B occupying the first place or the first chair and A occupying the second chair. So these are 2 different arrangements. अब फोटो अगर निकालोगे तो ये 2 डिफरेंट फोटोग्राफ्स होंगे. A लेफ्ट में बैठा है, B राइट में. यहाँ पर B लेफ्ट में बैठा है, A राइट में. So these are 2 different arrangements. Okay. I can also have A and C. So AC and CA. Or I can have, see, with AB I can have these 2. With AC I can have AC and CA. Then I can take BC also. Okay. So I may have BC and CE. I cannot have any more. So again, how many I am having? 1, 2, 3, 4, 5, and 6. So here also I have 6 arrangements are possible. Okay. There were 3 people, but I had taken only 2 out of them and arranged them in the order. How many such arrangements are possible? 6 arrangements. Okay. Now let us see if there are 3 people, but there is only one chair. There are 3 people and there is only one chair. Chair number 1. And I want to arrange only one people for the photograph, or I have to make them sit in the on this chair for a photograph. How many arrangements will be possible? Either I can make A sit on this chair or B or C. एक ही chair है. So how many arrangements are possible? 3 arrangements are possible. So if I'm having 3 people, I can select only one and put them in order. So how many arrangements I will get? 3. If I have 3 people and I select 2 out of them and put them in order, how many arrangements I will get? 6. And if there are 3 people and all 3 I have to take and select and arrange them in order, again I'm getting 6 arrangements. Okay. The same problem you can work for more than 3 people, or 2 people also, 4, 5, 6. Okay. Now our question is not to actually write down the arrangements. We would like to find out how many arrangements are possible. How many? We don't want to actually write, क्योंकि जैसे ही number ज़्यादा होगा, suppose there are 10 people, okay, and I want to arrange these 10 people for a photograph in a row or on a chair, then the number of such arrangements will be many more, not just 6. Okay, how many will be there? That we are interested in to calculate. Okay, so that is called as a permutation. So permutation is basically an arrangement. How it is denoted? Let us see. Here there are 3 people and I am taking all the 3 people and arranging them in the order. So it is denoted by 3P3. See what I'm doing? See, there are 3 people and all the 3 people I'm taking and arranging them in the order. So how many people were there? 3. And out of that, how many I'm taking and arranging? 3. So it is written as 3P3. See, this is the symbol. P for permutation. How many are there total? 3. And how many I am arranging? I'm taking out of these 3 and arranging. That is also 3. So it is 3P3. So 3P3 means what? Number of arrangements of 3 people or 3 objects taken all three at a time. Okay. How many we got here? We got 6. So 3P3, the value is 6. How many arrangements we got here? 6 we got. So 3P3 is 6. Okay. Look at here. Again, here also there were 3 people, but I was taking only 2 out of them and arranging them in the order. So there were 3 people in all and I am taking 2 out of them. So it will be written as 3P2. I hope you are understanding. There are 3 people ABC, but I am taking 2 out of them and arranging them in the order. So it will be written as out of 3, 2. So 3P2. And how many arrangements I got? I got 6 arrangements. So 3P2 is also 6. Let us see here. There were 3 people. Yes. But how many I was taking and arranging them in order? 1. So it is written as 3P1. And how many I got? I got 3 arrangements. So 3P1 is equal to 3. So let us summarize. If there are 3 people and I want to arrange them in order, so 3P3 is giving me 6 arrangements. 3P2 is giving me 6 arrangements. That is what we saw here. 3P3 is 6, 3P2 is 6. And 3P1 is giving me 3. Okay. I cannot have more than 3, no? 3 में से मैं 4 को तो नहीं select कर सकती हूँ. तो number of out of 3 I can either select 1 or 2 or 3. Not more than 3. 20 because I'm having only 3 people, right? Same way, you can find out 4p3, 4p4, 4p3, 4p2, and 4p1 and see what answer you get. Okay. As the number increases, if there are 3 people, 4 people, or at the most 5 people, then we can manually arrange them and count how many arrangements are there. But if the number increases, suppose there are 10 people or 20 people or 100 people, and I want to arrange them in order, I want to take out of 10 people, I want to take 4 and arrange them in order. So that means 10 out of 10, I'm taking 4 and arranging them in order. How many arrangements are possible? This will not be a very easy task to do it. So there is a formula which will tell you how many such arrangements are possible. Okay, we'll move ahead. So permutation means arrangement. Whenever I'm talking about the arrangement, order is very important. So that is what I have written here. Note, in permutation, in permutation, order is important. Why? See here, A, B, C and A, C, B, they are two different permutations. इधर order change हो गया है. B second place पे था, इधर third place पे. The people are same, but their order is changed. So order is important. They are giving you two different permutations. So permutation meaning arrangement, and order is important in permutation. So AB and BA are two different permutations. Okay. What is the definition? A permutation of R objects out of N objects. There are total N objects and we are taking R out of them. So it is written as NPR. This R can take value 1, 2, 3 up to, and it can take 0 also. Okay. No objects are selected. Is an arrangement of R things or R objects, R things or R objects, anything you can say, out of N things in a line. So what is a permutation? A permutation of R objects out of N objects is an arrangement of R objects out of N objects in a line. So permutation means it's an arrangement. Okay. Now the total number of permutations of N objects taken R at a time. There are total N, but we are arranging only R out of them, is written as NPR, P for permutation. And it is given by this formula. What is the formula? NPR is equal to N factorial divided by N minus R factorial. So number of permutations of N objects taken R at a time is written as NPR, and it is defined or calculated as N factorial divided by N minus R factorial. Let us see this. What is the formula for NPR? It is N factorial divided by N minus R factorial. Let us see what was our the problem which I gave you. I mean this example. There were 3 people. Okay. And we were arranging all 3 and we got 6 permutation. 3p3 ka value we got as 6. So let us see, do you get 6 by using the formula? So N is 3 and R is also 3. Find out what is 3p3 by using this formula. So NPR, N is 3, P is 3, N factorial, matlab 3 factorial, N ka value 3 hai, N minus R. So 3 minus 3, 3 minus 3 factorial. What is 3 minus 3? 3 minus 3 is 0, 0 factorial. And in the last lecture of factorial, I have given you that 0 factorial is always equal to 1. Note that. So 0 factorial is 1. So I am getting the answer as 3 factorial. And how do you calculate 3 factorial? It is 3 into 2 into 1. So that is 6. So therefore, what we got? 3p3 is equal to 6. And that is what we saw here. 3p3, 6. We got 6 permutations, right? So 3p3 is 6. Okay. Similarly, let us see what you get 3p2 by using the formula. So let us now calculate 3p2. 3p2. Okay, what is the formula for NPR? It is n factorial divided by n minus r factorial. So here n is equal to 3 and r is equal to 2. So 3 factorial divided by r means 2. So 2 factorial. Now what is 3 factorial? It is 3 into 2 into 1. And what is 2 factorial? 2 into 1. Oh, I'm sorry. 3 minus 2, not 2. N minus r, no? So denominator will be n minus r factorial. N is 3 and here n is 3 and r is 2. So formula is n factorial divided by n minus r. So 3 minus 2 factorial. So this will give you 3 factorial divided by 3 minus 2 is 1. So 1 factorial. So answer will be 3 factorial. 1 factorial is 1. So that answer is 3 factorial. 3 factorial is what? 3 into 2 into 1. That is 6. So again, what we got? 3p2 is also equal to 6. And that is what we have seen in the example. See here. 3p2. If out of 3, we are arranging only 2 people, then we are getting 6 such arrangements. So 3p2 we got as 6. Okay. Let us see what is 3p1. इधर हमको आंसर आया था कितना 3 आया था. Let us do 3p1 by using the formula. Correct? So I'm doing it here. 3p1. It is 3 factorial by formula divided by 3 minus 1 factorial. 3 minus 1 factorial. How much that will be? Okay. So by using the formula, 3p1 will be 3 factorial divided by 3 minus 1 factorial. So it is 3 factorial divided by 3 minus 1 means 2. So it is 2 factorial. What is 3 factorial upon 2? 3 factorial is 3 into 2 into 1. And what is 2 factorial? It is 2 into 1. This and this will get cancelled and you are left with 3. So what is 3p1? Therefore, 3p1 is equal to 3. And see, when we manually did it, we got 3p1 as 3. Correct? Out of 3 people, selecting 1 and arranging them, we got 3, either A or B or C. So 3 arrangements. So 3p1 is 3. So if you are given the formula, you can find out the arrangement or permutation of any number of objects. So the formula helps you in finding out number of permutations. Okay. So now you can find out what is 4p4. I told you, no, if there are 4 people and if you want to arrange them in the order, how many such arrangements will be there? So you can find out 4p4 and see what you get. It will be 4 factorial. Remember the formula. NPR is what? N factorial divided by n minus r factorial. N means जो यहाँ ऊपर लिखा है, r means यहाँ लिखा है. So 4p4, 4 factorial divided by 4 minus 4, 4 minus 4 factorial. So it will be 4 factorial divided by 4 minus 4 means 0 factorial. So that will give you 4 factorial. 0 factorial is 1. So it will give you 4 factorial. What is the value of 4 factorial? 4 into 3 into 2 into 1. So you will get 24. What does that say? If these 4 people are to be arranged in order, then how many arrangements you will get? 24 such arrangements you will get. Okay, if you can do it as a homework, write down all those 24. Some few I can write down: A, B, C, D, A, B, D, C, A, with A, I'm keeping fixed on the first place. A, C, B, D, A, C, D, B, A, D, B, C, and A, D, C, B. So look at here. With A on the first place, I have how many? 1, 2, 3, 4, 5, 6. 6 I'm having. What I have done, I've kept the first place fixed as A. Okay. Then second place, either it can be B or it can be C or it can be D. If the second place is B, then third place can be either C or D. So A, B, C or A, B, D. If third place is C, the fourth place will be D. So A, B, C, D, A, B, D, C. So when the first place is A, second place is B, I can have either C, D or D, C. So these two. Now first place A, but second place I have kept as C. So the remaining two can be arranged at BD or DB. So ACBD, ACDB. Then first place A, second place B already ले लिया, C ले लिया, तो D. First place A, second place D. So third place and fourth place can be either BC or CP. So ADCB. So with A as the first place, I'm getting how many? 6 I'm getting. Similarly, I can do when B is at the first place. Again, I'll get 6. With C as the first place, again, I'll get 6. And with D on the first place, in a similar way, I can do, again, I'll get 6. So 6 plus 6 plus 6 plus 6 will give me 24. So you do this as a homework. This will give you 24. So I can write 24 such arrangements. So with the formula also, I got 24. Okay. So with the help of formula, you can find out any arrangement of any number of objects taken any number, any value at a time. Okay. So a permutation of 4 objects taken 4 at a time, 4p4, 4p3, 4p2, 4p1, all this you can find out. Okay. So see that, take this as a homework. What homework? Find 4p4 by using the formula, of course, 4p3, 4p2 and 4p1. So you can use the formula to do that. And 4p1. And if possible, also try to write down those arrangements, because 4 is a small number, so you can do it. Okay. Now I have made a note here. What is NPN? Means out of n people, I'm taking n and arranging them in order. So you will get n factorial. See how? NPN. NPN means what? N factorial divided by n minus n, that is 0 factorial. So 0 factorial is 1, so I'm getting n factorial. Look at this, 3p3, what we got? 3p3 we got as 6 factorial now. 3p3 is 6, that is 3 factorial. यही मिला था ना हमको 3p3. How much we got? 3 factorial. है ना? So in general, I have written that NPN will be n factorial. And NPN minus 1 will also be n factorial. Matlab 3p, 3 minus 1 is 2. So 3p2 is also 3 factorial. See here, 3p2 also we got 6. Okay. So now let us solve some problems. So I hope you have understood what is permutation. Okay. So permutation is basically an arrangement, and number of permutations of n objects taken r at a time is given by this formula. NPR equal to n factorial divided by n minus r factorial. Now let us solve some problems. Look at the question. How many seating arrangements can be made for 5 students on 2 chairs and second one on 5 chairs? Look at the question. Try to understand. How many seating arrangements can be made for 5 students? There are 5 students and you have to make the seating arrangement on 2 chairs. The number of chairs are 2. So only 2 people can be. Out of 5, only 2 people you can select and put them in order. And in the second, all 5. Okay. Number of chairs are same as number of people. Okay. So see here, I'll take a blank slide. So in this problem, there are 5 students and you have to arrange these 5 people or 5 students for a photograph on 2 chairs. Okay. And in the second problem on 5 chairs. Look at the question. How many seating arrangements can be made for 5 students on 2 chairs and on 5 chairs? On 2 chairs, first one, and on 5 chairs. So there are how many students? 5 students. And in the first one, there are 2 chairs. So N is 5 and R is 2. So out of 5, you have to select 2 and put them in order. So there are 5 students. So there are 5 students, say A, B, C, D, E. But the number of chairs are only 2. So you are selecting out of 5. So it can be, how many arrangements will be possible? 5p2. Now find out what is 5p2. What is your formula to calculate NPR? The formula is n factorial divided by n minus r factorial. So n is 5 here. In this case, n is 5 and r is 2. So 5 factorial divided by 5 minus 2. 5 minus 2 factorial. So 5 factorial, 5 minus 2 means 3. 3 factorial. 5 factorial divided by 3 factorial. Now what is 5 factorial? It is 5 into 4 into 3 into 2 into 1. And what is 3 factorial? 3 into 2 into 1. These will get cancelled with this. So you will get 20. So how many arrangements are possible? 20 such arrangements are possible. See, this is what I have written. There are 5 students and 2 chairs. So N is 5, R is 2. So total number of seating arrangements will be given by 5p2. And then you calculate the value of 5p2. It comes out to be 20. Okay. 5 factorial, I have written 5 into 4. As I told you, denominator is 3 factorial. So actually 5 factorial is 5 into 4 into 3 into 2 into 1. But denominator is 3 factorial. So this much I can write as 3 factorial. So it will become 5 into 4 into 3 factorial. See, this is what I have written. And then 3 factorial will get cancelled. And you will get 5 into 4, that is 20. See how I have done here. Or you can write full way. That also you can do. Now the second one. This is the second one. 5 chairs. Okay. 5 chairs. There are 5 students and 5 chairs. So you have N is 5 and R is also 5. So total number of seating arrangements will be given by 5p5. Now calculate what is 5p5. So in the second one, there are 5 people, 5 students, and there are 5 chairs also. So now N is also 5 and R is also 5. So you have to find out how many different arrangements or seating arrangements are possible. Okay. Okay. So there are 5 students, A, B, C, D, E, and there are 5 chairs also. And you want to arrange these 5 people on these 5 chairs. So here N is also 5 and R is also 5. So how many such arrangements will be there? 5p5. Find out the value of 5p5. It is 5 factorial divided by 5 minus 5 factorial. Always remember the formula. N factorial, NPR is equal to, what is the formula? Let us write down the formula and then it will be easy for you to apply it. So what is the formula for NPR? It is N factorial divided by N minus R factorial. So it is 5 factorial divided by 5 minus 5, that is 0 factorial. So 0 factorial is 1. So you will get 5 factorial. Now find out the value of 5 factorial. It is 5 into 4 into 3 into 2 into 1. Kitna aayega? 120. So you will get 120 such arrangements. Okay. Let us go to the next problem. How many words can be formed by using all the alphabets of the word Delhi? there is a word Delhi, you have to find out how many different words you can form by the letters given in this word. So see, there are how many letters in this word? 5 letters. D, E, L, H, I. 5. Okay, they are all different letters, correct? We have to arrange them and find out how many different arrangements are possible. Okay, so these 5 letters can be arranged in 5p5 different ways. Again, find out the value of 5p5. See, in the previous problem also we have done 5p5 comes out to be 120. So 120 different words you can form. Okay, देखो ऐसा. For example, see, एक है DELHI और एक हो सकता है DELIH और एक हो सकता है DEHIL DEIHL. ऐसे आप करते जाओ अरेंजमेंट्स. There will be how many? 120. Okay, 5p5. Okay, I hope you have understood. So 120 different words can be formed by using the alphabets of the word Delhi. Okay. Next problem. How many words can be formed by using 4 different, look at here. How many words can be formed using 4 different alphabets of the word combined? Now here you have to find out different words by using not all the letters of this word, only 4 alphabets. So there are how many alphabets in this word? 7. COMBINE. There are 7 in number. 1, 2, 3, 4, 5, 6, and 7. In this word combined. We have to form words by using how many letters or how many alphabets? 4. So out of these 7, we are arranging only 4. So N is 7 and R is 4. So total number of permutations of R letters out of 7 letters is 7p4. So we have to find out the value of 7p4 here. See, unlike the previous problem, Delhi, in that you were permutating all the words. How many words can be formed using all the alphabets? Yahan par not all, only 4. So 7p4. It is 7 factorial divided by 7 minus 4, that is 3. So 7 factorial divided by 3 factorial. What is the value of 7 factorial? It is 7 into 6 into 5. This is 2 times it is 7 into 6 into 5 into 4 into 3 factorial. By mistake, this is typed twice, so just ignore it. 7 into 6 into 5 into 4 into, actually 3 into 2 into 1. But that is 3 factorial. So I have written here 3 factorial. And why? Because the denominator is 3 factorial. So this 3 factorial and this 3 factorial will get cancelled. And I will be left with 7 into 6 into 5 into 4. And if you calculate this, you will get 840. So therefore, total number of words that can be formed by using 4 different alphabets of this word is 840. Okay. So if you want, we can write here. If you have not understood, combine. COMBINE. How many words are there? 1, 2, 3, 4, 5, 6, and 7. But we have to form arrangements of only 4 alphabets from here. So that is 7p4. It is 7 factorial divided by 7 minus 4. That is 3 factorial. What is 7 factorial? 7 into 6 into 5 into 4 into 3 into 2 into 1. And what is 3 factorial? 3 into 2 into 1. This and this will get cancelled. And you will left with 7 into 6 into 5 into 4. How much? 820. Sorry, 840. 840. Okay. So these many arrangements will be, or these many words you can form by using 4 alphabets from this combined. Okay. Let us see the next problem now. In how many ways can the letters of the word Monday be arranged? Okay. Now in Monday, how many letters are there? 6, MONDAY. So in how many different ways you can arrange them? 6P, 6 different ways. The answer is coming as 720. Okay. How many of these arrangements begin with T, with M? And how many begin with A? Let us see how we have done it. See, MONDAY. How many letters are there? 1, 2, 3, 4, 5, 6. So my first question is what? In how many ways can you arrange all the letters of this word? So there are 6. Okay, so 6P6. So first one is very simple. That is 720. 6 factorial. That is 720. How many of these, look at the second question. How many of these arrangements begin with M? We want to count only those arrangements which starts with M. See, arranging these numbers means I have to fill how many places. I have to make them arrange. That means I have to 1, 2, 3, 4, 5, 6. Okay. In the second question, what it says, how many of these arrangements will begin with M? Means the first place should be M only, fixed. Okay. So the remaining, how many places are there now? 5. Remaining 5 places can be arranged by the remaining 5 letters in 5P5 different ways. Because first one to fixed ho gaya, M. Okay. And what is the value of 5P5? It is 5 factorial. When you apply the formula, 5 factorial, 5 minus 5 factorial, that is 0 factorial. So the answer will come out to be 5 factorial. That is 5 into 4 into 3 into 2. 20 into 6, that is 120. So number of arrangements which begin with M will be 120. Let us look at the next one. How many will begin with M and end with A? Okay. How many arrangements of these letters will begin with M and end with A? So in that, what we want? It should begin with M. There are how many words? MONDAY, correct? So the first one should be M and the last one should be A. Now how many are remaining? 1, 2, 3, 4. There are total 6 now. 1, 2, 3, 4, 5, 6. So I want to find out how many arrangements will be there where the first place is M and the last place is A. So first and last is fixed, M and A. So now how many I have to fill? I have to arrange the remaining 4 letters. That can be done in 4P, 4 different ways. The answer will be 4 factorial divided by 4 minus 4, that is 0 factorial. So answer will be 4 factorial. 4 factorial means 4 into 3 into 2 into 1. So I'm getting the answer as 24. So see, whatever I have explained you, the same thing I have tried to written here, right here. There are 6 letters in the word Monday. Arranging these 6 letters means filling the 6 places. If the word has to begin with the letter M and end with the letter A, first and last position is fixed. Okay, first place is filled by M and the last place is filled by A. The remaining 4 places can be filled by the remaining 4 letters in 4P, 4 different ways. So the answer will be 4P4 and that is 24. Okay, so this type of problem you have to practice. Thank you so much. I hope you have understood. Thanks a lot.